Welcome back, class. Let's take a look at this concept called percentage composition. It seems like on many of these lessons, I always say this is a fundamental knowing or skill needed for chemistry, but there are a lot of fundamentals that are needed, and this is one of them. Let's just start by breaking down just the concept of the words. When we talk about percentage of something, then we always know that usually represents some sort of portion. Okay, a percentage of something is a portion, and you get that portion, a portion of something, right? And you get that portion by using a fraction, right? By looking at some fraction. All right. For instance, you've got a pizza, and all of these slices are 100% of it, but what fraction right now is there that is colored in yellow? Well, we can see that there's 1 out of 1, 2, 3, 4, 5, 6 pieces, so 1 out of 6. So that's going to equal a certain percentage, right? You just take 1 divided by 6, 1 divided by 6, right? So that gives us, I'll just go ahead and work this out for you, make it a good lesson just in case, some people need a reminder of this. Anytime you've got a fraction, you always are essentially multiplying by 100 to turn into a percentage. So in 2 steps, 1 divided by 6 would be 0.166666667. It just keeps going and going, and eventually there's a 7, right? So if we multiply that by 100, we now get 16.66%, right? So it's approximately 16.67%, right? So that's the portion fraction percentage of this pizza, of this pie, so to speak, right? Composition just means what it's made of, right? So if in this case, if the pizza is made up of pepperoni and sausage, or we could go back to this thing here. Let's just say we're looking at this. We see that there's all of these things that had blue dots in them, and then there's all these pieces. Pretend that one did not have yellow in it. And then we see this here. Then, we could say that there are 3 out of 6, right? There's this one, and this one, right? 3 out of 6 that have those dots in there, right? Well, we know that that's 1/2 times 100. We know that that's going to be, 50%, right? 0.5 times 100 is going to be 50%. And then if we were to look here, we see that there's 1, 2, right? So there's 2 out of 6 that have the blue dots, correct? And so 2 out of 6 would be the same as 1/3, all right, times 100, right? Well, we know that's 0.333, and that 3 just keeps going. So if we multiply by 100, you're going to get about 33.33%, about, 33%. It's about 1/3. We know this already, right? Now, if we're talking about in chemistry, if we're talking about an element, for instance, or compounds, in this case, what we're talking about is the fraction, the portion, the percentage that is the elements that make up that particular compound, right? So for instance, if we were to look at copper 2 sulfate, we could see here that in this, if we had 1 molecule of this, we can see that there's 1 copper, there's 1 sulfur, and then there are 4 oxygens. And so as a portion or a fraction or a ratio, right, we can go back to this, and we can break this up again, where we have 1, 2, 3, 4, 5, 6 pieces, just to represent the concept of all the parts together, right? Well, one of these is copper, 1 is sulfur, and we have 1, 2, 3, 4 that are oxygen, right? And so we could look at the percentage composition of just the number of parts in this case, and we could figure out the percentage, right, the frequency of the elements in the compound. But what we do most often is we look at percent composition. We look at percent composition by mass, okay? And the reason we do that is because every single element has a different average mass. The mass of copper is different than sulfur. Even though there's one copper and one sulfur, they each have a different mass. So while they might be in number the same portion or fraction in this example, they are not the same mass of the total mass. So if we knew what the mass of copper was, the mass of sulfur, and the mass of oxygen, we could figure out the total mass of this particular compound here, and then we could then figure out what's the percentage composition for copper to sulfate, right? Well, let's just jump in. Let's do that. All right, let's go ahead and clear this board. Go ahead and get all this out of here. All right, I'll erase all this. Let's actually do that. All right, so we go back. Remember, we've got our copper to sulfate. So go back to some previous lessons where we use our periodic table and we use the mass of the atoms on the periodic table to figure out essentially if we had one molecule, what would the atomic mass unit be for that for each atom in that molecule, right? So I'm not sure if you've already watched a video where we talk about the concept of a mole. If you haven't, then don't worry about it. There is another video you can watch, but there's two ways to explain this. So whether or not we were to look at, so remember, go back to the periodic table. And so, for instance, copper, right? Let's go ahead and zoom in. See how we have the 63.546, right, for the copper. So in class, we've been using about 63.55 because we said that's what our scales are balanced to, right, to the nearest hundredths place. That's our estimated digit. Well, if we were to look at one molecule of this copper 2 sulfate, just one molecule of it, right, then we would say that there would be one atom of the copper, and that one atom would be that 63.55 AMU, right? Now, a mole is a much larger unit. Again, there's another video about that. So if you've already watched that, you'll understand this. But if you haven't, just a quick recap. A mole is essentially a unit in chemistry, like the concept of 1 dozen. So it actually is a larger unit than that. So a dozen is always 12. Whether or not you're talking about eggs, or if you're talking about cars, or you're talking about people, a dozen is always 12, regardless of what it is you're counting. But that dozen always has a different mass because the parts, the substances are different. Well, if we had one molecule of copper 2 sulfate, there would be one atom of the copper here. Well, if we had 1 mole of the copper 2 sulfate, then there would be 1 mole of copper in that mole. It's the same ratio. And so for that reason, we can still use this number, 63.55. All right. So let me go ahead and clear this board here. All right. And again, if that's a little unclear, there'll be a video that's talking about a mole and the relationship there. You're going to want to watch that and take some really good notes. All right, in the meantime, let's jump in and do some math. All right, some very basic math. There is no new math here to learn. We're just applying the math that you've already learned into all these chemistry concepts, okay? All right, so what we have to do first is we need to figure out number one, what is the mass of the copper 2 sulfate, right? Well, let's do that. Let's figure that out. So we've got copper, we've got sulfur, and we've got oxygen, right? And so this should look familiar, where we have copper, and remember we've got 1 copper, 1 sulfur, 4 oxygens, and then we multiply by the mass. We just saw that copper was 63.55 AMU, right? And so now we just need to go and look at our sulfur, right? And so we come over here, we see sulfur. Remember, it's a non-metal. We got a 32.066, and in class we've been using 32.07, right? So we're going to come back here. We're going to put 32.07 AMU, atomic mass units, and oxygen. Remember, back over here again, 15.999. We've been using 16.00. All right. That's AMU. All right, so we just have to multiply all that out. Of course, this would still be 63.55 AMU. This would be, this would be 32.07 AMU. And then 4 times 16, that's 24. So what, that's 64.00 AMU, correct? So now at this point, you can just see that it's just a matter of adding up everything together. 64 plus 32.07 plus 63.55, double check my math, but when you add all that up, you should get 159.62 AMU, okay? All right, so now, knowing that, I'm gonna just move this information up here. So we've got 159.62 AMU, right? That's the mass of this. All right, so now what we need to do is ask ourselves, what's the portion of this that is copper? What's the portion that's sulfur? What's the portion that's oxygen? And if we think about this, this is the total. That's the total mass. And so let's think about this just for a second. Whenever we want to know a percentage of anything, so a percentage of anything, right? I don't care what it is, anything. In this case, it's going to be elements or compounds or something like that. But take anything; it doesn't matter. Go back to the pepperoni and the pizza or whatever. You're just looking at the parts, right? A percentage is always a fraction. On the denominator, the bottom, you always have your total on the bottom, which represents all of it that could be there, right? That 100%. And then on the top, you always have the portion, the amount that you're counting, right? You always have that portion that you're counting. And then, of course, to make it a percentage, you always have to multiply by 100. And so, this basic concept you've been taught for years. Now we're just going to apply it here, all right? So percentage composition, so we can figure out that the percent of copper would have to be this divided by the total. Would have to be 63.55 AMU divided by 159.62 AMU. And then just like we have up here, we have to go times 100, okay? So 63.55 divided by 159.62, that gives, and then times 100, right? And multiply by 100 just moves your decimal over a few several decimal places, right? Right? So we'll do this in two steps for you. So, when you do all that, you end up getting 39.8133. There's a bunch of other numbers, right? We have more than we need, but I'll just write these down. And then 0.66, 3066, right? All right. So we don't need all those numbers. So what we do is we're going to go ahead and do the calculations for sulfur, do the calculations for oxygen, and then we'll figure out how many of those numbers do we need, and it makes sense that all of our numbers have to equal up to 100%. And when that happens, we know we would have done our work correctly. All right. So I'm going to go ahead and just move this out of the way just so I can keep everything on the page, right? So I'm going to move this. I'm going to move all this up here, All right. So we would have that. And so now we need our percentage of sulfur, right? And that percent, and I'll just draw a line here to separate it out. Or that might be confusing some people in the past. I've gotten confused if I do that, so I won't. So percentage of sulfur, well, sulfur we see is the 32.07. So this is the portion that is sulfur divided by the total times 100. And I did neglect to previously, the same unit on top and bottom, they will cancel out. Okay, so don't forget to be thorough with your math. Sometimes I forget to do that, but I know it's there. All right, so 32.07 divided by 159.62 times 100. You should have something like 20.091467. There's a bunch of numbers, and of course, that is percentage. Okay. Percentage oxygen. All right, that is the 64. So 64.00 AMU divided by the total. All right, everything is always about the portion divided by the total, whatever the 100% is. So we can cross those units out. So 64 divided by 159.62 times 100 gives us 40.09522. There's some other numbers. And of course, this is percentage. All right. So now what we want to do is, let's see. We are going to add all these together. So we've got 2 decimal places on each of our numbers. When you add or subtract, you tend to go at least after the decimal place. So 2 seems to be it. So that means we would want to have all of our sig figs to that point right there. And if we have to make adjustments, then we'll make adjustments. And that is the part about evaluating, is that you follow rules, but then you make adjustments so that the rules make some sense in a real world situation. So let's just take this. Let's take 39.81 plus 20.09 plus 40.09. And when you add all those up, you get 99.99%. All right, so that means one of these we need to round up, so that one of these we need to round up because we need to figure out where to get this here. We need to figure out where to get that value right there so that we can get our 100%. All right, we're missing 0.01 right now. So what we do is we take a look and ask ourselves, all right, will this 3 round that 1 up? And we know the answer is no. Will this 1 round that 9 up? We know the answer is definitely a no. So now we have a 5. 5 do not always round up. However, in this situation, we know that 0.095 is closer to 0.10, because 9 can round up to 10, that 5 makes this value closer to the next one than this 1 does this one right here, or this 3 does this one right here. So this is a situation where we realize that we stick with this, all right, and that our final answer for this one would have to be 39.81%. Our final answer for this one would have to be 20.09%. And our final answer for this one would have to be 40.10%. So if we add 40.10% plus 20.09 plus 39.81, and you should see that there's our 100%. So 40.10% is the percentage composition of oxygen in this compound. 20.09% is the percentage composition of sulfur in copper 2 sulfate, and 39.81% is the percentage composition, the fraction, the portion of copper in this particular substance. And this is how you do this. This is how you can figure this out for anything. It doesn't matter which substance it is, what the molecule is. It doesn't matter. This is how you can approach doing it. Now, the good news about this is it doesn't matter what your sample size is. And what I mean by that is it doesn't matter if we had 1 gram of copper 2 sulfate or 10 grams of copper 2 sulfate, a million grams of copper 2 sulfate. The percentage would always, by mass, would always be this much. So let's put this into a concept that makes sense. We just finished saying that copper is 39.81%, that all of these, and 29.09 and 40.10, all those add up to 100%. So let's think about this. If we had a 100 gram sample of copper to sulfate, and I'm getting 100 grams because we're just working with 100%, well, then that means that we go back over here, that 39.81% would be copper. So that means that 39.81 grams would be copper. We go back and we see 20.09%. And so if we have a 100 gram sample, you just think of your grade, right? It's the same thing. At 20.09% that's your grade. It's the same thing. Or, I'm not saying it is your grade, but you know what I mean. So then 20.09 grams is the sulfur. And then 40.10, we can see there's the oxygen. And so 40.10 grams is the oxygen. Add all that up, there's your 100 grams. And so that checks out. It checks out. All right. If we had a 10 gram sample, well, these percentages are the same. So you would just do the exact same thing. And you would get similar numbers, but they would just be smaller if we think about it. So if you have 10 grams and you go times 39.81%, right? Because we want to know what's the mass of copper in this situation. Well, we would take 10 grams times the 39.81, and that's the same as 10 grams times 0.3981, right? And so 10 times 0.3981, you should see that gives us 3.981. See, notice it's the same numbers, just the decimal went from here to here because we're working with 1/10 of the amount. So it just moved it 1/10 of a decimal place over. Okay. And so if you were to take 10 grams times 20.09%, you would get 2.009, right? So if you had 10 grams times the 20.09%, right? So that's 10 grams times 0.2009. You're going to get 2.009. Of course, that was grams. That was grams, right? And then again, if you had 10 grams times the 40.10%, so that's 10 grams times 0.4010. And so we know that that is going to be 4.010 grams. And if you add up if you add up 3.981, 2.009, 4.010, you get 10 grams. So it always is going to work out because the fraction never changes. It's the same substance. So the portion, the ratio has to stay the same. Okay? Hopefully that helped. Please go back and review, take notes, and remember this is going to apply to any and every substance, molecule. I don't care if it's we're talking about type 1, type 2, complex, polyatomic ions in compounds, molecular compounds like water or methane or something like that. It works for all of these, right? You just have to figure out what do I need to know and how can I get my ratios, my percentages, my fractions. All right, hope that helped. I'll see you in another lesson real soon. Stay curious and bye.